Why algebra is hard.
Oh, a topic dear to my heart, John. I'm looking forward to this one.
Excellent. So, I don't think algebra is as hard as fractions, but I still think
There you go.
I still think it's quite hard.
Not as hard as fractions.
I think fractions are really hard though.
I'm feeling so chuffed because I kind of get fractions.
Well,
this is giving me some hope.
Let's see how we go.
All right.
So first of all, if I was to say 3 plus 4 equals question mark, could you tell me what question mark is? 7. Okay, so you've just done algebra.
Oh, nifty.
That's
nifty.
That's the easy part of algebra.
Okay. Right.
Only because there might be more than one question mark, we just call it x. So 3 plus 4 equals x. So what's x equal to? 7. Where it gets a little bit trickier is if instead of saying with 3 plus 4 equals x, we say 3 plus x equals 7.
Mm-hmm.
Any idea what x would be there?
Oh, I know that one.
Yeah, what's
4.
that one? 4.
Yay! Get the crowd all up.
But so, first reason that algebra is hard is equals means the same, not has the answer of. So right through school, you can go 3 plus 4 has the answer of 7. But as you kind of develop more nuanced understanding, you go, no, they're the same, exactly the same thing. And what it means when they're the same, say 3 plus x is exactly the same thing as 7.
That is such a kind of. I know we chatted about this a while ago, but just hearing it again, to me, that was another big turning point. That shift from what is it again? From we're taught
it's the answer of,
yeah,
but it's actually exactly the same thing.
So the phrase is when you see equals now, it means it's exactly the same as the stuff on the other side.
Yeah. And what that means is if it's a bit more, like you can do that in your head, but if it's a bit more complicated, what you want to do is get x on its own. So whatever we've done to one side, we can undo it using the opposite. So there's a 3 there, a positive 3 there. We can take 3 away from that, and provided we do the same thing to the other side, they will still be equal because they're the same thing. So we're taking 3 from the left, and if we take 3 from the right, they're still going to be exactly the same thing.
Yes.
Those 3's cancel one another out, plus 3, negative 3. And what that leaves us with is x equals 4.
Yeah.
That's
okay.
Basically,
so more beauty there, you know.
There's more beauty there. There is more beauty there.
The mental block I feel I used to have, I may still have it, was when the letter came in. But you've explained that really well. I remember being in school and being quite good at the numbers, and all of a sudden there was this letter. But by that little exercise we did there, so x is just the thing we don't know.
Yeah.
X is question mark. Nice. Okay.
Except when it isn't, we'll get that.
I knew there was a catch somewhere, but
it was going to be a little bit harder than that.
Yeah. Okay.
Okay. So that's one thing. Just making that conceptual shift.
Yeah.
Equals doesn't mean the same as has the answer of. It means it is exactly the same as.
Right.
Okay.
That's quite helpful.
Second reason it can be hard is there can be a lot of assumed knowledge and a lot of things which in primary school you go, well, why would I even bother learning that? But you kind of actually need to know it to get to algebra, or the algebra doesn't make sense. So some of the things are double negatives, multiplying negative 4 by negative 3 is positive. If you're not familiar with that, we do cover that in the book, How to Love Statistics. Distributed property of multiplication, we have a video on that. Using brackets and the fact that brackets say do what's in the bracket first. Priority of mathematical operations, which we haven't really looked at on videos, but basically you raise something to a power first, you multiply before you add.
Oh yeah, I remember them.
Remember those things?
Coming back.
Raising to powers, we've got a video on that, and roots, and fractions and ratios. And if you don't know those things and you come to algebra, it's really easy to get stopped and to lost and get blame algebra. In fact, what often happens is people miss the earlier bits.
Bit. Yeah.
They haven't realised that.
And or they've missed, can I just blame my teachers, you know, if that's okay.
For sure.
Yeah, I don't really mean this to all you teachers out there. But I'm aware that because I hit algebra and the wheels fell off for me, but it's a really interesting proposition that it's the bits before that. So somewhere in that bit before is the missing link that was why algebra didn't make sense to me at the time. It does more now.
Yeah. And mathematics is like that. If you're away for one day or just in a bad mood one day, not paying attention, you miss one bit, and nothing else makes sense after it. Which makes it challenging.
Which goes back to that idea that we've talked about it being a build. Which I didn't. Until we started talking together, I didn't realise that it was just mathematics was just this unrelated series of topics. But if it's a build, then like you're saying, then you need to know, get your head around the previous stuff in order to be able to do the next bit. Yeah, which is algebra.
Exactly right. So the third reason it's difficult is because X looks like X.
Yes.
So the idea that, because we used to kind of, so you go, oh, what does that mean? The X that's used should be italic, but can be pretty hard to know. The way algebra gets around this is that just, from now, you spend all this time in school up to this point learning that sideways cross means multiplied by. Now you just ignore it, just leave it out, and you don't need it, because otherwise you'd confuse it with X. So you might say 3 with X in brackets. That means 3 multiplied by X. You won't see the cross anymore, or just 3X. Or sometimes when you've got numbers together, you just put a big dot between them, because you've got to have something. But you typically, once you start doing algebra, suddenly you stop using the X for multiplication altogether.
I feel relieved about that. I'm not sure why. But
because
one less thing to remember.
That's right. So 3X is just 3 multiplied by X.
Yeah.
And it seems a bit funny at first, but once you get used to it, you go, I don't miss that.
Sort of seriously, my gut reaction was going, phew.
That's right.
I'm easily pleased.
So the fourth reason, because X doesn't always mean the unknown quantity. There's other things it could be. Exactly. So you remember we did a video on hypotenuse's theorem. On Pythagoras' theorem. And we talked in there about the short side, the middle side, and the hypotenuse of a triangle. And so if we were to call the hypotenuse Z and the short side X and the middle side Y, then what we can say is that X squared plus Y squared equals Z squared. Or if you're in America, Z squared. And that's just a statement of what happens to always be true if you're talking about a right angle triangle. So we can use letters not just as something you need to find, but as an expression of the relationship that numbers have in certain circumstances.
Okay, we're going to hover on that.
Is that?
Let's go on. I get it. I can sort of glimpse it, but maybe you keep going. We'll get there.
No, I don't want to leave this. So we can use it. It's like setting up a formula for something, like a program we can shove other things into.
Okay, I've got it.
So we can slot numbers into that.
Okay.
And so what that is saying is that once you know something's a right angle triangle, and if you were to measure the sides. And if you were to call one X and one Y and one Z, then that would always be true.
Right,
it's
so that's
saying. It's describing the relationship between the numbers. It's not telling you need to find something. It's just, you might call it a formula, you might call it an identity. But so we're not always trying to find something. We can just be using, there's still question marks, but they're using it to say, in this circumstance, this relationship will hold true.
And regardless of what specifics you put in there, i.e. specific numbers, those relationships between those entities will hold all the way through.
Exactly right. So that's, in fact, that's a lot of the power of this. It's not just finding a thing, but it's enabling us to move in. Think about mathematics as a language. It's now enabling us to make bigger statements and say this will always be true no matter what numbers you
regardless of whether you're what sort of triangle is it again?
A right angle triangle.
Regardless of whether the right angle triangle is too tiny or whether it's the size of a building, that will always hold.
That will always hold. So you call that an identity, and the letters are a handy way to express that. And in fact, that's probably a more important use of algebra than finding X. Just being able to say general things that are true, which is then what lets us extend build bridges and
build different bridges,
basically live in the modern world. If we didn't have this mathematics, we'd still be living in caves.
We'd
have to be.
So I should be grateful to mathematics. Shouldn't I? I'll work on that.
So you should, or even not grateful, just to kind of go, I have some understanding of the language that allows the world to exist. I've got, it's not.
That's nicely put. I like that.
A complete mystery to me.
Yeah.
And so it's largely this shorthand way of saying these things will be true.
It's also like, even as we're talking about this, I'm realising like it's the demystifying, which I know is your great passion when it gets to statistics, but generally to go, no, even if I don't understand all mathematics, I can at least, for me anyway, I can at least see some of the architecture of it.
Yeah,
which is
and
cool.
architecture is a good idea. It's a good word for it. So it's a plan you can then put specific numbers into. But here we've got a blueprint that we can work from on it.
That was a bit of an epiphany, John, by the way.
Oh, yeah. Excellent. The fifth reason, because variables stick together.
Variables stick together.
We call the x and the y variables because they could be anything. And you see something like that and go, yuck! I have no idea.
Yeah, I'm just in the fetal position right now.
That's just horrible. What do you do with it? Well, what we can do with that is make that a bit simpler. And so what we'll do is kind of go, well, all right, that 1x there, 1x minus 1xy in the middle, we can just call that xy. And the x on the end, if we've only got one thing where x is multiplied by nothing, so we'll just call that x. We've got two things where we've just got numbers together. And we've got two things there where we've got a number multiplying x to the fourth. So x to the fourth is this making sense, or am I losing you? No, you hear that?
It's a bit complicated, but I'm getting the thread.
Getting
I
the
think.
concept.
So,
okay, good. One thing there, we've just got y multiplied by a number, and we've got two things with xy in them. We've got minus xy and minus 6xy. And so if we simplify this by pulling it all together, we can add. It's not a lot we can add to x, we don't know enough, but if we've got plus 2x to the fourth minus 2x to the fourth, well, those two, that's like we're adding something, we're taking it out, so that'll just disappear. 2y will sit there on its own, minus xy minus 6xy, well, that's actually, we're going to have minus 7xy, and plus 2 minus 1, we're going to have 1.
Okay.
So
we're starting to see all these things we've been talking about in the other videos all coming into play.
Coming together. Yeah. So that those 2x to the fourth minus 2x to the fourth, well, that's just going to disappear. And minus xy minus 6xy, well, therefore we're going to have minus 7xy's. And plus 2 minus 1, well, we're just going to have 1. And so we've simplified it a whole lot. So that's become that because those variables stuck together. So there's it still doesn't, you still don't know what that means. You don't have enough information. But you can simplify things by bringing things together like that. And
that's kind of, well, my take out that was the application of a lot of those things we've been working on in other videos to get to do that. And if nothing else, for me, that just takes away the terror of seeing that first run of numbers and just kind of going, I couldn't possibly do that. Now with those tools I can go, okay, we can break this down.
Chip away at it and see where it's
a good way to put it. Yeah, terrific.
So those 5 reasons are the reasons that algebra is hard, and apart from that, it's not what you do. You can do some simple things, you can do some complicated things, but that's the essence of algebra.
Wow.
That's the whole of algebra. Well, not the whole of what you do with it, but if you get that, you understand algebra.
Terrific.